Hey Pre-Calc, Miss Sola here with the start of Unit 4, conic sections. During this unit, and especially today, this introduction, there's going to be a lot of drawing of 3D shapes. So I'm going to need you to kind of be very careful to listen to the explanation to know exactly what what it actually is, what the image actually is. Conic sections. Okay. Four 4.1. All right. So a conic section is a cross section, essentially a slice of a cone. So first, before we start slicing cones, how to create a cone or this type of cone for this class. So the cone, to create it, we're going to rotate two intersecting lines. Okay, so that's going to look something like this. And this cone in this world, and for conic sections, these lines are going to continue forever in both directions, right? And so I want you to visualize if I were to take these two lines and rotate them around a vertical line, like where this is the vertical line through that intersecting point. If I were to rotate these two lines around and around and around, it would kind of create a bunch of circles through here. It would make this type of a cone. But what's cool about this cone is it's not like an ice cream cone where there's like an end or a bottom. This would kind of continue forever in both directions. So it's also up here. It's going to be rotating around, rotating around, rotating around. So this is the idea of the cone. And a couple of things about this cone. First of all, because I took two lines and rotated it, it is hollow. So when we're slicing it, hollow, it's really just the lines. So when I'm slicing it or taking cuts of it, I'm also going to be getting like hollow pieces or like just the parts of the line that it's intersecting with all of my slices. The other thing to keep in mind is it is infinite. All directions. All four. Right, so it's gonna this would continue to spinning all the way down here and all the way up here. So this cone will continue to get wider and wider and wider. So again, if I'm taking a slice of it, maybe a vertical slice, that will be an infinitely tall vertical slice. And I'm gonna start with the easiest that I think to visualize, which is the circle. So there are kind of four different ways I can take a slice of this cone, and four different shapes I'd get depending on how I slice the cone. Okay, so when we're talking about a circle, that is, I'm going to take a flat plane, imagine a piece of paper cutting across this cone that is perpendicular to the base. The cross section, the plane that intersects cone perpendicular. No, parallel to the base. So if I were to draw, I'm going to draw kind of like a piece of paper looking item here. Something like this, right? And I slice it right through the middle. And it's going to intersect this cone at this piece. And if I were to turn this cone and like look at it head on, the shape that I get there is a circle. Like the intersecting piece is a circle. Okay. Now, if I were to angle this piece of paper a little bit, we're going to draw, let's see, I'm going to draw another cone. So 2 intersecting lines, rotate it around, right? This is the basic structure for the cone. Goes forever, goes forever. If I were to intersect this cone with not a plane that's parallel to the base, like not one that's cutting it right in half, right horizontally in half, but one that's angling a little bit. Like if I were to have this kind of circular thing and I'm cutting it at an angle like this, you're not going to get a circle. So let's see, let's draw this like plane. So if I were to cut it like in this direction, I guess. So where it's going to intersect, it's going to kind of come like down like this way and like this. And this ends up looking kind of like an oval. It's called an ellipse. When the plane intersects one nape of the cone, this is like the bottom nape area and the top nape. So if a plane is only intersecting one part of the cone there at an angle, just one nape, not parentheses, of cone at an angle, it forms an ellipse. And so this shape, my circle looks like this, right? Your ellipse is going to look like this. And it's like, pretend that that's perfect. It's wider than it is tall, or it's going to be taller than it is short, than it is wide. So it'll either be longer left to right or taller up and down. This is an ellipse. Then I've got I was going to try to do it there. I don't think I can fit. We can try it. So if I've got my cone here, I'm going to draw just kind of the base one. So there's not too many there. If that plane is angled a little bit more so that it doesn't connect to make like a full circle, it kind of is connecting the side to into the base a little bit more. So this will look something like this. Let's see. Sometimes it's parallel to the original intersecting line. So when you slice it this way, straight through somewhere like that, you'll get this shape. And this is actually the exact shape of a parabola. So a plane that is intersecting like from the edge to the base. And this will go on forever and go on forever. Intersects from the edge to the base of cone. And so this will end up looking like a perfect symmetrical parabola. We're going to dive way deeper into that, learning points like there's a special point around here that this parabola will turn around. There's a special line up here that it's going to be equidistant from in every sense. So we'll dig a lot more into that. But if you cut the cone in this way, slice it at an angle, it's going to cut into a parabola. Okay. I saved the best for last, I think. The fourth type of conic section is called a hyperbola. This is going to be like the graph that is the branches of a rational function. And this is if I'm going to slice the cone and it will intersect both napes of this cone, both the top and the bottom of this cone. Maybe it could be a vertical intersection. And if I were to do that, hard one to draw. So something like this. Right? It's going to intersect in two places, like here and here. And it's going to create this, again, these will continue forever. They will be opposite of each other. And so it'll end up being this kind of shape that we will be able to map with angled diagonal asymptotes and again many different properties of intersections of where and how it matters. We're going to be able to write equations for all of these four different kind of conic sections and map it onto a two-dimensional graph. A hyperbola, this is where the plane intersects both napes of the cone. In this case, this one was a vertical. I'm going to post a video of somebody who animated all of these cones and like turned them around so you can see them at all angles. It might be clearer than my couple of drawings here. But take your time to really get to know how these shapes are formed with the cone. Because everything in the rest of this unit is based off of how this plane intersects with the cone and how this plane intersects with the cone and how this plane intersects with the cone. So take your time getting to know.